learners, welcome to today's geography lesson. My name is Nomthandazo Malembe. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Parama Research and Development. So in today's topic, we're going to focus on the June exam preparation. So remember, what is included in your June exam to prepare for June exam? We are looking at your question paper will have two sections, which is section A as well as section B. So under section A, you will have climatology questions that will be worth 40 marks, and you will have geomorphology questions that will be worth another 40 marks, and then you will have settlement questions that will worth another 40 marks. That is your section A. And then for your section B, you will have your mapwork questions, which is worth 30 marks. So in breaking of the questions, or this is how the questions will be set. We're looking at the 4 questions that you will have in your question paper, and all 4 questions are compulsory to answer. So you've got your section A as well as your section B. So in question 1, you will have your short questions, which is worth 10 marks, and then you will have your medium and your long questions, which will be worth 30 marks. So when it comes to the short question, you will have your figure 1.1 with 5 questions, which is 1 mark each, and your 1.2, which is a 1 mark each, and then you'll have your medium and long questions. That will be your figure 1.3, your figure 1.4, which will be 15 marks each. So the total per question is 40 marks. So in terms of geomorphology or your climatology or your settlement, this is how the setting of the paper will be. 10 marks for short questions, and then medium and long questions will be your 30 marks. So when it comes to your section B, this is your mapwork questions. You are looking at the map skills and calculation. They will be included. It will be 10 marks for both the map skills as well as the calculation. And then you will have your map interpretation. Map interpretation will worth 12 marks. And then you'll have your GIS question, which will be out of 8 marks. Then the total will be 30 marks. So let us get into our question 1, which is your weather and climatology. So you've got the questions there from the previous question papers. Remember, it is also important to revise the previous question paper so that you can see how the questions are asked and how you should answer. So you've got our first question there as question 1.1, which is the match column A as well as match column B. So you will realize now this is the new style that they use for column A as well as column B. You will be given 2 options whereby you need to choose from those 2 options. So like I've said, your short questions will be 10 marks. So this is your 5 marks questions. The first one, which will be your 1.1, and then secondly, it will be your figure 1.2 with another 5 marks questions. So what you're going to do, because this is part of the revision, so you are preparing for your June exam, which will be sitting for it very soon. So you've got the first question there, which is question 1.1 with 5 questions. So what I'm going to do, each and every question will be 1 minute. So after 5 minutes, because you have 5 questions, then we will be able to go through the corrections together. So you need to write all the answers down so that you can be able to compare them when we are doing the corrections. Like your first question, it says the winds that cause mid-latitude cyclone to generally move in an easterly direction. So there you need to know what is the general movement of a mid-latitude cyclone and what causes the mid-latitude cyclone to move in that way. And then secondly, you've got the causes, the development of cumulonimbus cloud in the mid-latitude cyclone. Another thing you should know, what causes the development of mid-latitude cyclone. And then you've got the type of occlusion. Remember, this is the stage of mid-latitude cyclone, which is the occluded stage. Then it is differentiated into 2. So now you need to tell what type of the occlusion. And then number 4, the weather station indicates a backing of the winds. in the southern hemisphere. So you must be able to identify with the weather station the backing of the winds. Then question number 5, the air pressure from A to B in the sketch below. So you must know what does the air pressure from A to B. You realize A, it's a warm air, and at B, it's the cold air. So we are talking about the air pressure. So like I've already said, each question will be allocated 1 minute. So after 5 minutes, we're gonna do the corrections. So don't forget to write your answers down so that you can be able to compare your answers when we are doing the corrections. Right, grade 12, I hope everyone is done. So looking at our first question there, which is what causes the mid-latitude cyclone to generally move from the easterly direction? So you do know the mid-latitude cyclone, they move from the west to the east. So what causes it? Because the initial stage is at the west, which means you are given Y as well as Z there. Y is the easterlies and Z is the westerlies. So what causes the wind that causes the mid-latitude cyclone to generally move in the easterly direction? We are looking at the answer Z, which is your westerlies. So again, you mustn't waste time writing the full answer. You are given the option Y or Z. So as soon as you are certain about your answer, you just need to write an alphabet only. So if it's Y, you write Y. If it's Z, you write Z. So our answer there is Z. So if we confirm, it's also Z. And then what causes the development of the cumulonimbus cloud in the mid-latitude cyclone? Again, you must know the mid-latitude cyclone, remember we said we recognize it with the cold front as well as the warm front. And then you need to know between these two fronts, which one is influenced by the cumulonimbus cloud, as well as there is another one that is influenced by the nimbostratus cloud. So here we are talking about the cumulonimbus cloud, which is influenced by the cold front. So here we are looking at our options, which is the cold dense air forces the warm lighter air to rise. And then at Z, we are looking at the warmer lighter air that moves slowly over the cold dense air. So you will remember when we were still learning that the cold front is faster and it is heavy or it is dense. Therefore, it is able to move fast as well as to attack or to catch up with the warm air or with the warm front, whereby it will be lifted. As it is lifted, you do know that it condenses and then your cumulonimbus cloud will form. So therefore, the correct answer there is Y. So if you may check, yes, the answer is Y. So let us come to our question number 3. Our question number 3, it says the type of occlusion indicated at A. So how will you identify, is this a warm occlusion or is this a cold occlusion? In grade 10, you have learned about the symbol of these cold fronts. So you do know that the cold front is represented by a triangle a symbol, as well as the warm front is represented by the O or the half O. So what you do, you check the last one, which one is indicated or which one is the last symbol of the cyclone, or which one is the last symbol of the front. So looking there, the last symbol is the warm front. So which means this is the warm front occlusion. Hence the answer is Y. So this is another easy way to identify between the occlusion. So if it was a cold front that was at the first here, so it means it will be a cold occlusion. Then we're moving to number 4. Our number 4, it's a weather station, indicates the backing of the winds in the southern hemisphere. So you do know generally the winds move in the southern hemisphere, they move in clockwise, and in the northern hemisphere, they move anti-clockwise. So when it comes to the backing of the winds, they are the opposite. So if they are the opposite, it means in the southern hemisphere, they move anti-clockwise, and in the northern hemisphere, they move clockwise. So if you're looking at the weather station there between Y and Z, which one is moving anti-clockwise? So it makes the answer to be Z. So let us check. Yes, the answer is Z. Then we're coming to question number 5. Question number 5, it says the air pressure from A to B in the sketch below. So at A, it's a warm air, and then at B, it's a cold air. So the air pressure, it decreases, then it increases when it reaches the cold air. So we are looking there at the option as Y. So hopefully you managed to get a total. If you didn't get a total, you do realize where you made the mistake. Right, we're moving right along with our figure 1.2. Remember, we said the short questions will be worth 10 marks. So your 1.1 will be 5 marks, and then your figure 1.2 will be another 5 marks. So you are given a synoptic weather map. There will be no question paper without a synoptic weather map. So obviously you must be able to read the synoptic weather map. You've got 4 questions that could be displayed now. So after that, there is a next one, which is the 5th question, because it is long so that it can fit properly, or for you to see it clearly, it's on another slide. So let us go back to question 1.2.1 up to 1.2.4. So the questions are based on a synoptic weather map. The first question, it says the air pressure at A, which is the Walvis Bay, is approximately. So here you need to go to the synoptic weather map. So we are looking at A, which is this one. This is our A. So we need to look at the air pressure there. And then secondly, the high pressure at B is known as, we are looking at B, which is the high pressure. Remember, we've got the 3 high pressure cells that influence the weather in South Africa. And then question number 3, the synoptic weather map depicts the winter conditions due to, so this is the combination, which means you need to choose carefully. So the synoptic weather map depicts the winter conditions due to, then you need to fill in there due to, and the descending air, and the conditions over the interior of South Africa. So you must have the 2 combinations there. So your Roman figure 1, which is weak, your Roman figure 2, it's strong, and your Roman figure 3, it's the cloudless, and the Roman figure 4, it's your overcast. Then you must make the combination, then you choose A, B, C, or D. Then our question number 4, it says the weather conditions of Port Elizabeth in the enlarged at sea is influenced by. Then we are looking at the options there, A up to D. So I'm going to give you 4 minutes to answer these questions. And then after 4 minutes, we're going to move on to question number 5 with 1 minute. And then after that, we do the corrections. Right, I hope everyone is done with that 4 minutes. So this is our 5th question. So you will have again the 1 minute, because it's 1 minute per question. So weather station below will represent D on the synoptic weather map if there are the following weather changes in the area. So here you need to calculate. This is our weather station at a D. So looking at our weather station at D here, you've got the temperature there, as well as the dew point temperature, and you've got your wind direction. So you need to take from the weather station, which is this one, in an enlarged position, so that you can see properly what I'm talking about. We are talking about the temperature, we are talking about the dew point, we are talking about the wind direction, as well as the cloud cover. So the question is asking, if there are the following weather changes in the area. So Roman figure 1, we are looking at the decrease in temperature of 4, and then we are looking at the increase in dew point by 8, and the wind direction changes to the southwest, and the wind speed increases with 10 knots. So let's see if you will be able to come up with a combination. So you've got A, B, C, as well as D. Remember, the answer lies with this information that you are given. So 1 minute so that you calculate, and then after 1 minute, we're going to do the corrections from 1.2.1 up to 1.2.5. Right, learners, I hope everyone is done. So let us start with our first question. Our first question, it says, what is the air pressure at A? Approximately, which is the hectopascal, your HPA. So you are looking here at A. You've got the isobar with 1020, and we've got the second isobar with 10 and 16. So if you are going with this isobar, it is going in this direction. So it means this is the first isobar for 1020, which is 1020, and then the second one is 1016. So the A that we are looking for is here between the 20 as well as the 16. So let us look at the options. You've got option A, which is 1020, definitely not, because it's not at A. Then we've got the 1018. So if we are looking at option B, 1018, we've got 20 and then 16. So in between here, because it is moving in pairs, which is 2. So our answer here is supposed to be B, which is 1018. Because if you're looking at option C, it's 1016. 1016 definitely is not located at A, and we're looking at 1014. So 1014 we don't have because we've got 1012. So therefore, the correct answer there is B. So if we're looking at the options there, yes, the correct answer is B. So our next question, it's 1.2.2. The high pressure at B is known as, remember you've got the 3 high pressure and you must know their names as well as their allocation. So you've got the South Atlantic at A. So South Atlantic is at this position, so therefore it's incorrect. And then we've got the Kalahari. Kalahari is supposed to be situated in the interior here, so therefore another incorrect answer. Then we have the continental. Continental, remember, it's an alternative name for South Atlantic, so therefore it's also incorrect. Hence, our answer is D. So remember, D is a South Indian at the eastern side. So if you may check our answer, yes, our answer is D. So let us move to the third question. The synoptic weather map depicts the winter conditions due to we are looking there is a weak or there is a strong. Remember, in winter, we've got the strong descending air, which is the cold air. So our option 1 is the strong, and cloudless conditions. So you've got the strong as well as the cloudless condition. Remember, during winter, we don't have clouds because there is more of the cold air that is dominant. So therefore, there is no warm air that is rising, which means the clouds cannot form. So we are looking at a Roman figure 2 and we are looking at Roman figure 3. So hence our answer there is C, because the winter conditions, the synoptic weather map depicts the winter conditions due to the strong descending air. And again, how do you identify the air is strong? By looking at the isobars. they are close to each other, which means there is a strong pressure gradient. And the cloudless conditions. Again, we're looking at all the weather station there. The cloud cover is clear, which means it is depicting a winter with the cloudless conditions. So we can safe to say our answer is C. So if you may check again, our answer, yes, it's C. Then we're moving right along to our fourth question. The weather condition at Port Elizabeth in an enlarged at sea is influenced by the offshore winds. So our option there is A, the offshore winds. Remember, it's the winds that are coming off the interior of to the ocean. So that is our option number A. Then we're moving to our question number 5. Our question number 5, you were supposed to calculate. So if I may go back in our synoptic weather map, you've got the air temperature there with 26. So the question says decrease the temperature of 4 degrees. So 26 minus 4 will give you 22. So what does that mean? It means option A and option C are completely out. And then the increase in dew point temperature of 8. So the previous one was a 4. So 4 plus 8 will give you 12. So you've got B, you've got D with the temperature of 22 and the dew point of 12. So both. So Roman figure 3, the wind direction changes to southwest. So there is the key. So from here, it was northwest because it is between the north and the west. Then the wind direction changed to the southwest. So if we are looking there in the diagram, so it is D that the wind direction is the southwest. So again, we might say we have reached our answer. But now let us look at a Roman figure 4. Roman figure 4, the wind speed increases with 10 knots. So we started with the 5 knots there. So if they increase with 10 knots, which means they are now 16. They are now 15. So they are now 15. So here we've got the long one which represents 10 and the short one which represents 5. So it is giving us a 15. So if we're looking at the options there, D is the most correct one because of all the things that are required. It is perfect at D. So our answer is D. Then we're moving right along to our figure 1.3. So figure 1.3, it's where you're going to get your medium as well as your long questions. So you are given the stages of the tropical cyclone. Remember, in our syllabus, we are studying 2 cyclones, which is the mid-latitude cyclone as well as the tropical cyclone. So the mid-latitude cyclone, they occur in winter, and the tropical cyclone, they occur in summer. So again, you must know how to identify this is a mid-latitude cyclone and this is a tropical cyclone. So remember, the mid-latitude cyclone are recognized by the fronts and the tropical cyclone, we recognize it by the eye. So we are given a diagram there, which is diagram A and diagram B, and there is a cross-section of a tropical cyclone. So you've got the questions there, question 1.3.5 up to question 1.3.5. So I'm going to give you 10 minutes to work on these questions. And then after 10 minutes, we're going to discuss the corrections. So likewise, don't forget to write your answers down so that you can be able to compare the answers. Right, I hope you are done. So let us look at our first question. In which hemisphere did the tropical cyclone develop? So you are given there the diagram with the cross section. If you cannot identify which the movement of this tropical cyclone. In the cross section, you can see the arrows are going anti-clockwise. So by now, you're supposed to know the movement anti-clockwise is in the northern hemisphere and clockwise is in the southern hemisphere. So your question 1.3.1, in which hemisphere did the tropical cyclone develop? We have the northern hemisphere. So how do we tell this is the northern hemisphere? Because of the anti-clockwise rotation of A. Then second question, you name the stage of development. So remember, tropical cyclone, it has 4 stages whereby there is an initial stage, there is an immature, and there is a mature, then a dissipating. So remember, in a mature stage, we say the eye is fully developed. So we can clearly see the eye there. So which means at A, it is a mature stage. And then our question number 3, which one of the stage A or B is represented by the cross section of a tropical cyclone? So remember, in a cross section of a tropical cyclone, you do have the eye in the center, and then you have the eye wall at the side, and then you have your cumulonimbus cloud. So looking there, it is represented by A. So our question number 4, it's a follow-up question. You need to give a reason. Why are you saying it is stage A? So you reason there because the eye is fully developed. So then we move to question number 5, which is your 1.3.5. There you need to refer to the eye as well as the eye wall. Remember, when you were still studying, there is a difference between the eye as well as the eye wall. We're saying the conditions around the eye are stable and the conditions around the eye wall are unstable, which means if the tropical cyclone hits the particular country or area, the section whereby it will be covered by the eye, there won't be any impact because the conditions are stable as compared to the areas where will be covered by the eye wall. So there, you need to differentiate between the air movement in the eye as well as the eye wall. So remember, you must know the conditions. So in the eye, we are saying there is a descending air dominant. Why descending air? Because we are saying there is a stable conditions. So in the eye wall, there is a rising air dominant. Why? Because there is unstable conditions. Remember, it's where your cumulonimbus cloud will form. It's where your heavy rainfall accompanied by the thunderstorms in the eye wall. And then your B, it's a paragraph question. In a paragraph of approximately 8 lines, you explain how the air movement influenced the weather conditions in the eye as well as in the eye wall. So you are looking at the eye. The eye, we are saying there is a descending air. Descending air, it means the air is sinking, remember? So with the air that is sinking, there will be clear a cloud cover, or it will be cloudless, or due to the clear skies, or due to the descending air, which means there will be no formation of clouds. And also, there will be little or no wind because of the weak pressure gradient. And also, there will be no rainfall, which will occur due to the lack of moisture. Remember, the air is descending. For the rain to occur, we need the air to rise so that it can condense and the clouds form. Then we're looking at the eye wall. The eye wall, we are saying it is a rising air. So why? There is a strong air, rising air, which causes the cumulonimbus cloud to develop. So once the cumulonimbus cloud develops, therefore, the heavy rainfall will follow. And also, we are looking at the latent heat, which drives the system. Remember, for the tropical cyclone to be alive, it needs a lot of the latent heat. So that is your paragraph question. Then we're going to figure 1.4. So your figure 1.4 is another question which worth 15 marks. Remember, figure 1.3 is 15 marks and figure 1.4 it's 15 marks again. So that the medium and the long questions are equivalent to 30 marks. Then you've got the infograph below about the bear winds in South Africa. So clearly you need to read the extract first before you answer the questions. And then you've got 6 questions there and you need to draw. In question 1.4.5, you draw a weather station of the East London that illustrates the wind direction, the cloud cover, and the air temperature at 1. So I'm going to give you another 10 minutes so that you can be able to answer the questions first before we discuss the corrections. So after 10 minutes, we will be discussing the answers. So don't forget to write your answers down so that you can be able to compare them. So 10 minutes, we're going to do the corrections. Right, I hope everyone is done. So let us look at our first question. It's saying, what, according to the extract, the importance of reading the extract, was the result of the record a breaking heat wave in the East London? So we are looking there. Is the peak temperature of 43.9 degrees Celsius or the bare wind conditions? All these answers, you get them at the extract. And then the second question, why does the air get warmer as it descends towards the coastal region? So you will remember that the air gets warmer because it heats up adiabatically. And then the third question, according to the graph, how long did the maximum temperature of the 44 degrees Celsius last? So if you are looking there at the graph, as well as at the hours. We are looking at 44 there. So it lasted between 35 up to 40 minutes, or you can say it is less than an hour because you cannot be certain. So less than an hour, it is also accepted. Then the fourth question there, you need to explain the reason for the northwesterly direction of the bare winds in the satellite image. So there we are looking at the anti-clockwise. Remember the question is asking about the northwesterly direction. You do know in the northwest, in the north hemisphere, the air rotates in an anti-clockwise, and in the southern hemisphere, the air rotates in a clockwise. So the anti-clockwise circulation of air from the Kalahari descends down the escarpment. That's your answer. And then question number 5, you were supposed to draw there. In what you are drawing, you are supposed to show the wind direction as well as the cloud cover and the air temperature. So if you're taking a look at this weather station, it doesn't have a north because the north, it indicates the wind speed because we are looking at the wind direction, which is at the northwest, and the 44 degrees as well as the clear cloud cover. So 1 mark for the correct wind direction and another 1 mark for the degree and the 1 mark for the cloud cover. And then question number 6, how will the physical, which is the natural environment, be affected due to the time? Answered in question 1.4.3. Remember we said it is lasted in less than an hour, that it has been exposed to the 44 degrees Celsius of the bare winds. So you can imagine how hot it was. So we are looking there, the moisture will be evaporated from the soil and the vegetation, so it increases the danger of the fires and it decreases the humidity. So any of the two. So from figure 1.1 up until figure 1.4, it's where your 40 marks is covered. So next, we are looking at the question 2, which is the geomorphology. So again, the setting will be the same, 5 questions for 2.1 and another 5 questions for 2.2. Then we're looking at 2.3 as well as 2.4. So you've got the column A and column B again. Remember, you are given 2 choices in column B where you need to choose one answer. So I'm going to give you another 5 minutes to go through the questions, and then after 5 minutes, we're going to do the corrections. Right, girls and boys, I hope everyone is done. Looking at the first question, an area drained by a river system. So you've got Y as a catchment area. So definitely it is incorrect. Remember, a catchment area is an area where the rain falls. And then Z is the drainage basin, which is correct. So our answer there is Z. Then we're looking at the second question. The letter A on the sketch below is, the letter A there, it is between the tributaries. So if it's between the tributaries, we are looking at Y, which is the interflow, as well as Z, which is the watershed. Remember, watershed is separating the two drainage basins. So whereas the interflow is separating the two tributaries. So the correct answer there is Y. Then we're looking at our third question. Illustrate the source of the river. Remember, the source of the river is where the river begins. So if we are looking there at Y, the river is bending there. So if the river is bending, which means this is not the source, this is not the beginning, it's in the course. Then we are looking at Z. At Z is where the river will begin. So therefore, the correct answer there will be Z. Then the fourth question, we are looking at the upper layer of the saturated zone of groundwater. Remember, there is a difference between a water table as well as the groundwater. So the upper level there, we're looking at the water table, which is Y. Then our question number 5, the rate of infiltration. Remember, infiltration is when the water is infiltrated or it is seeped into the soil. So the rate of infiltration will be higher in the areas where there is the evaporation is slow or the evaporation is rapid. So we are looking there at Y, which is the evaporation is supposed to be slow, so that the infiltration will be higher. And then we're moving to our question figure 2.2. So figure 2.2 is a multiple choice. So remember, in the multiple choice, you will have those combinations where you need to give 2 answers. So you've got the first question there whereby you need to refer to the drainage pattern. So you remember when we're still studying that the drainage pattern, we have the 7 in total. So there you are given a particular one. So it's a diagram that represents a particular drainage pattern. So you've got options there, A up until D. And then you've got question 2.2.2, which means it's a combination. So you've got this pattern develops on the following underlying rock structure. So you've got the Roman figure A up until the Roman figure 4. So you've got the combination again. And then you've got the third question whereby the tributaries join the mainstream at which angle. So you've got 3 questions for now, which is displayed so that you can be able to see on the screen. And then after 3 minutes, I'm going to display the last 2. So 3 minutes, if you can please go through this one, you write your answers down. And then after 3 minutes, I'm going to move to the next slide so you can have your question number 4 and your question number 5. Right, your 3 minutes ends now. So let us move to the next slide. So you've got your question 2.2.4 as well as your question 2.2.5. So with this question, you refer to the dendritic drainage pattern. So they've already given you the name of this drainage pattern. So you need to, the stream order at A, I hope you still remember how we calculate the stream order. And then the drainage pattern usually flow on. We're looking at the combination there on the slope and in the valley. It's another combination. So I'm going to give you another 2 minutes so that you answer this. And then after 2 minutes, we're doing the corrections. Right, let us start with our first question. Our first question, it says the drainage pattern is known as A, it's a trellis, B, it's a centripetal, and C, it's a parallel, and D, it's a radial. So looking at the sketch there or looking at the diagram, it represents the trellis. Remember the trellis, we are saying it's an alternative rock of hard and soft rock. So you are looking there. The mainstream are parallel to each other and they are joined with the short stream. Those are the characteristics. So the answer there is trellis. So if you can check, yes, our answer is A. And then we're moving to the second question. This pattern develops on the following underlying rock structure. There is a rock with uniform resistance to erosion. There is a folded mountain, and there is areas where volcanoes erupt and the hard and soft rocks formation. So we are looking there at the folded mountain, yes, as well as the hard and soft rocks, which means our answer there is C. So then we're going to look at the third question. The tributaries that join the mainstream at the acute angle or the right angle or the oblique angle or the obtuse angle. We are looking there at the right angle, which means it is B. Then we are looking at our question number 4. Our question number 4, it says the stream order at A. Remember, when we're calculating the stream order at A, we're saying the first tributaries are automatically the stream order number 1. So for you to move to the next stream order, you must have the 2 stream orders that are the same. So therefore, you have the stream order 1 and the stream order 1. Stream order 1 with another stream order 1. So if these 2 stream orders, they give stream order 2 here, then we have another stream order 1 and stream order 1, it gives 2. So therefore, there is 2 stream orders. So there is another 2 stream order and another 2 stream order, which means here at A, it will definitely be stream order number 3. So we're looking at our answer there at C. And then looking at our question number 5, we are looking at the drainage pattern usually flow on a steep slope. That is why, because it has so many tributaries. So it is flowing at a steep slope and with the shape of the U shape, a valley. So we are looking at option number D. And then we've got our figure 2.3. So our figure 2.3, it is taken or it is referring to the river profile. So there you've got the 2 types of river profile. So there's one there with A and B, and then there is one there with X and Y or C and D. So our first question, it says identify the 2 types of river profile. And then secondly, you need to differentiate the shape of this profile A and B. And then thirdly, you explain why there is a differences between the shape of the profile A and B. And in figure 2.3.4, you refer to the river profile C to D. Is it a profile graded or ungraded? And then B, why is the lake regarded as a temporary base level of erosion? And at C, you explain why the river grading differs at X as well as Y. So again, I'm going to give you another 10 minutes, and then after 10 minutes, we're going to do the corrections. I hope everyone is done. So looking at our first question there, you need to identify the two types of river profile. So you've got the one at A and B, which is showing the shape. Remember this one, we call it a cross transverse. And then the one at C to D, remember we call this a longitudinal river profile. So there we've got the longitudinal and the cross or transverse profile. And then to differentiate between the shape of the river, of the profile A and B. So you've got the shape there at A, it is a V shape, and at B, we call it a U shape. And then thirdly, you need to explain why there is a differences between the shape of the profile. So remember, the shape is determined by the type of erosion. Remember at A, the type of erosion, there is a vertical erosion, which means that is how that the V shape is created. And then at U, it's in the middle course or in the mature stage where the river is eroding at the side, we call it a lateral erosion. So if you may check them, at profile A, the erosion is mainly vertical or downward erosion, and at profile B, the erosion is mainly lateral or the sideways. And then the following question is the profile. We are now in question 2.3.4a. Is the profile graded or ungraded? Remember, for the profile to be graded, it has to be a smooth concave. So looking at that one, it is not smooth and there is a lake in between, which means our answer there is ungraded. And then B, why is the lake regarded as a temporally based level of erosion? Remember we said the river there is temporarily stopped. So the lake is temporarily preventing for further erosion, but however, the erosion will eventually take place over time. And then at C, we are looking at, you need to explain why the river grading differs at X as well as at Y. So remember there, you are given the causes. So at X, because it's an upper course or it's a youth stage, the process that is dominant there is the erosion. Remember, the river undergoes two processes, which is the erosion and the deposition. So you need to know on which stage or on which course is these processes dominant. So at X, the erosion is dominant due to the various neck points, and also the river still needs to undergo a graded, so therefore there is more erosion. So this river is still eroding so that it can be graded. And then at Y, we are looking at the lower cost. So at the lower cost, which process is dominant? It is the deposition. So at the lower cost, it is characterized by the deposition. Hence, it is a balance between the erosion and the deposition. So there, the river is overgraded because of the deposition, which is dominant. Then we're looking at our figure 2.4. So figure 2.4, you are given a sketch which shows a river capture. So remember there is a river capture which is before as well as the river capture which is after. So the first question you need to define what is a river capture for 2 marks. And then second question, which letters represent the following features of the river capture? So I always tell the learners at A, it's a capture stream, and B, it's a misfit stream. So when you are writing the answers as well, you need to indicate A, which alphabet is represented by the capture stream, and B, which alphabet is represented by the misfit stream. So don't just write the answers, but you need to indicate. Then at number 4, name a flavial landform that might occur at the elbow of capture. You will remember it's one of the reasons or it's one of the evidence that the river capture has occurred, the elbow of capture. And then number 4, what is the economic importance of the landform caused by the headward erosion? So you will remember the headward erosion is when the source of the erosion is lengthened backward. And then In the paragraph question, you need to explain the process of the river capture. So I'm going to give you again another 10 minutes, and then after 10 minutes, we're going to do the corrections. So, grade 12s, I hope you are done. So looking at our first question there, the river capture, there are so many ways that you can define this. So what is more important is the river capture is when one river steals water from another river. So here you must emphasize that the river that will be able to steal from another river is the one that is more energetic, and it is stealing the headwaters of the river that is less energetic. And then the capture stream, it is remember the capture stream is the one that steals water, or is the one that keeps water. So you are looking there at before the headward A capture, it is the river A that is heading towards the watershed that is separating the two rivers. And then at B, you've got the misfit stream. Remember, the misfit stream is that short stream that will be left after river capture has occurred. So you are looking there at the D. So D, as you can see there, because there is a gap in between, so D, it will be left as a misfit stream or as that short stream. And then third question, name a flavial landform that might occur at the elbow of capture. So we are looking at the midpoint waterfall. Remember, at the elbow of capture, it is here at C. So hence it is a midpoint. And then your 2.4.4, what is the economic importance of the landform caused by the headward erosion? Remember, it is going to erode the headward or the watershed. So therefore, there will be gorges. So the gorges are the tourist attraction. Hence, the question is asking about the economic importance of this landform. So we are looking at the gorges. It will become a tourist attraction. And then paragraph question, where you are supposed to explain the process of river capture. So basically, how does the river capture occur? We are looking at the river A is the stronger due to the steeper gradient and the high volume of water. Remember, there is a reason why the river will become energetic again. When the river is flowing at the steep slope, or when there is a high rainfall, so obviously there will be a high volume of water. And the river is lower on the watershed, and therefore the river A has more energy than river at D. And then the river A lengthening its course through the headward erosion, and the watershed, it cuts through the watershed. And then we are looking at the river A, which captures the waters of river B. And therefore, this capture takes place at the elbow of capture. Remember, when this river is now returning with the waters from another river, it's where your elbow of capture will be. So this is the process of the river capture. So if we were to summarize our lesson today, we have done the climatology, we have looked into the mid-latitude cyclone, the tropical cyclone, your synoptic weather map, as well as your berg winds. And in the geomorphology side, we have looked at the stages of a river, we have looked at the drainage pattern, and we have looked at the stream order, your river profile, as well as your river capture. So hopefully this was enjoyable, and you will now be ready for your June exam. So remember, your June exam, there is a climatology, geomorphology, settlement, and map work. So with this lesson, we did not cover settlement as well as map work, which means on our next lesson, we're going to cover those two so that you can be fully prepared for your June exam. So hopefully you have learned as much as possible in this lesson. Thank you, and stay tuned for the next one.